running, and we get to see the argument where we stored that, and then we'll call the original to make sure it is saved and ran. Look at that! The small primitive little proof of concept for our import address table hooking is working just fine in our custom malware. Now we can expand that just a little bit. Let's add some other functionality to hook into some other API functions. Let me close out of this, and I'll hit enter to get out of the malware running. But now let's go tweak our source code back inside of our malware.c source code, where we defined our create file hook. We built up this little prototype definition here. We want to do the exact same thing, follow the same procedure, but end up creating a new hook for our write file API function. Now I'm going to copy paste this one. I am going to just cruise through it for the sake of time here. But look, it's the exact same setup and structure. We define write file with its own type definition, have a tracker for the original API function call, and then build out the new function that we want to call. Now I'm doing something interesting here just to showcase it. We are going to print out that we have hooked the contents of the file here. We've hooked that API function, and what we'll do is we'll actually add to the buffer or the stored text written in that document. All we're going to do is simply add hello, just maybe some trailing string at the very end there, and concatenate that on to the stuff that's being saved. Of course, we call the original function, but because we've modified and tampered with the parameters, we now know and we can control what is actually in that file. Now, of course, if we do that, we do need to update our actual run malware function so we can create that hook. Let's go ahead and right after our create file W, make sure that we can steal the original hook as well for the write file function. We'll use our exact same hook IAT, get module handle replacement, and carve it out to get the write file function. Now we can display, we have stolen just the original value for create file W and write file, and ultimately our hook will be called instead. Let's compile and build all of this. Let me see if I can run that one more time. No errors, looking good. So I'll go do the exact same test. We'll get back to our command line. We'll make sure Notepad is running. I do want to restart because again, hey, it'll be running in the memory space of that executable, of that process. So I'm going to start from a fresh one here. But let me go ahead and run the exact same command. Just up arrow on my keyboard. I'll hit enter, and look at that. Now we have found the hook. We have staged and we've compared what the original function would have been. We can display that out here. But let me get back to our Notepad instance, and let's say this is from John. Give Maldev Academy a try. We'll go ahead and save this. We can just call that maldev.txt on the desktop. Now, you won't see it in this Notepad buffer, in this window right away. But checking out our debug console, looks like that ended up being closed. But if I open Notepad one more time, and then I actually go navigate to our maldev.txt file, automatically it has added our hello function. Because that's all that we told it to do, but we could manipulate and tamper with those parameters and arguments however we want it. We have literally hooked the function. Isn't that so cool? Like, we have literally laid the foundation, put out the groundwork, and built the structure and skeleton for us to write more custom malware where we can easily retrieve whatever functions we want with our own natural get proc address and get module handle replacements, and then we can modify, manipulate, and tamper and hook into any other Win32 API function. That's just so cool. I think it's awesome. I hope you didn't mind the little bit of Notepad demo. A small, simple thing, but it gets the point across that we can control what happens on the machine. And hey, we get to learn all about that with Maldev Academy. If you haven't given them a try, seriously, there's a lot of incredible material there. And please, 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 start at the beginning. Start with the rand of all the courses and all the modules that are necessary. I know they're always adding new updates, but don't start with the updates. Those can be a little bit overwhelming if you're still just diving in. Try to see where the sweet spot is of knowledge you already have in the course material that's already presented. I know I've seen some YouTube comments that it can be a little bit tough to dive into everything. But anyway, sorry I want to take it. Please, 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 huge thanks to some of the sponsors, incredible out there, and thanks so much for watching. Like, comment, subscribe. I'll see you in the next video. Sorry. What What's up, everybody? Welcome back. My name is John Hammond, and you know, I love me some malware analysis, and it seems like you guys do too, so we're doing it a little bit once again. I'm gonna hop over to my computer screen here where all the good stuff's going on, my computer boy, and I've got this folder here. I'm in this Kaspersky directory, and this one I think is kind of fun. I think this is a neat story. It's a little bit peculiar, but we'll tinker and we'll play, right? So there was this little Kaspersky shortcut, or kaspersky.lnk. And whatever, in the comments you can line if it's Kaspersky or Kaspersky or whatever. That shortcut file linked to this Kaspersky.exe. Now, that was in the directory of c:\windows\Kaspersky, which is not, by the way, the actual default installation path for Kaspersky, the antivirus program. And you can verify that by simply Googling. You can see, hey, I was kind of looking for ILSpy to grab that and play with that a little bit. But if we just look for like, yo, what is the Kaspersky installation path? Pass the hash, like that PTH acronym there. You can change the installation path of Kaspersky. By default, the application is installed in the folder program files, Kaspersky Lab, Kaspersky Endpoint Security, etc., etc. It is not normally in C, Windows, Kaspersky. So that was a little sus, you know. Kaspersky is sus in this case. I'm not positive, hey, what is that thing? And we kind of want to look into it. I also saw in the directory of C Windows Kaspersky an update.exe. And inside of the directory was also all of these other files that were put into the related folder, so we know that they were kind of in that present directory. So I'm sure you can see already by some of these file names, those look peculiar, and not actually all of them are in here. Some of these other DLL core folders, core files, DLL, all those other DLL libraries that can actually end up pulling all in, but I do want to showcase some of these here, and I'm doing a little bit differently, right? So you can see I'm in a virtual machine. I've got just flat Ubuntu in here, and I also have another machine that's just running Windows over here, so we can kind of bebop back and forth. And I don't have to do rig on the new machine, so thankfully I can run some virtual machines side by side and do some other neat, cool, fun stuff. So what I want to do, first of all, is take a look at what the files that we have are, right? So Kaspersky.exe is, of course, a Windows executable, but it is also a mono.NET assembly. That means we can kind of peek and kind of peel behind the layers, look behind the curtain, and see what that thing is actually made of in something like the nspy or ILSpy. So I actually wanted to get ILSpy on this Linux machine, and then it's like, oh no, you actually need to end up using the Avalanchia, or I honestly don't remember how that's called or pronounced, but that's the cross-platform edition of ILSpy, so I was like, all right, let's just roll it up then, because we have that, and we might be able to do some other cool, fun stuff with it. So let's hop on over to that Windows version, and I've got this terminal here. My laptop that you might have saw off in the corner is actually hosting a web server right now, so we can pull down that Kaspersky.exe and those other files. So laptop, desktop, working in harmony, you know, good stuff. Let's get over to my desktop so we can do some neat stuff, and I'll get this down. I'll go to my laptop's IP address. That was 10.0.0.98, so a local thing here. Should be on port 8000 because it's just a simple Python HTTP server. And I want to grab that Kaspersky.exe, and it whines. Okay, we need to use the basic parsing parameter. So that should be use basic parsing, so that pulls it down without a problem. I should just kind of make that full screen, sorry. There we go. But it wouldn't have saved it because I didn't specify an out file. So let's run that wget command one more time. Let's specify an out file, and we'll call it that Kaspersky.exe. Okay, now that should be downloaded. Good. And I also want to get that update.exe because we are going to explore and take a look at what that thing is. Perfect. And they should both be on my desktop now. Oh, what is that? What is that icon? I feel like I've seen that icon before. I'm just going to open that up in File Explorer so it's behind a white background. Kaspersky with a B file description, and version number is 1.0.0.0. Oh, okay, fascinating. Let's just steal that picture, and let's see if we can like do a Google image reverse search on it. I'll just save it with Paint. I'll slap that like whatever in my desktop. I don't care if it's called Untitled. That's totally fine. Here we go. But I want to know where that comes from. Like, is that genuinely a thing? Google image search. Yeah. Okay. Cool. Search by image. Let's upload that image. That was on my desktop with untitled.png. Oh. It's literally it's the logo or thing for Kaspersky. I see. Kind of neat. That's kind of funny. So you can probably tell, like, hey, I'm kind of riding this train that this might not actually be Kaspersky, right? It's a facade. It's a decoy. It's deception. Let's take a look at what that update.exe is first before we dive into our little Kaspersky spooky thing. But that update one is seemingly very small. So if I ls, right, again, there's not a lot in there. Oh, that's the image. Update.exe. I didn't even download the right thing.
Ow. Ow.
Let me know. All right, let's remove.
Stop it.
Update.exe. We also don't need that image. But we will download that time and actually get the correct file there. Let's grab the update one.
Oh my fucking god.
Size, the exact same size on both files. No. This update is much smaller. So let's crack that open, shall we? I have my ls file opened up here, and let's go ahead and open on my desktop that update.exe. See, that has a different icon because it's a different binary. Gotcha. All right, so this is using some reflection libraries.
Fucking swing!
Might be able to do some peculiar things. Let's open it up and explore some of those other libraries or things that might include. Nothing seeming metadata. I guess that's just kind of like the library headers and everything for the file itself. Resources. Do we have anything in here? Not displayed for me. For update and update properties. Resources. That doesn't look like it's all that interesting code. Let's just go into the update form, right? Let's see what this thing does. I guess I can expand all these, and we just initialize a component. So this is a graph user interface, right? So like we could run this and actually copy a window to public, and I might do that once we're done, kind of looking around and analyzing this thing. It is a GUI. So dispose, we'll just remove it. Those are, I think, boilerplate stuff for when you end up having a like Windows Forms. And it just sets a font. Okay, so the program is probably where the fun stuff actually happens. Let's see what we do.
Are you fucking
Check
kidding
for
me?
some arguments here. And the argument that is supplied, is that arg0 going to be the program itself? Get processed by ID and parse args into, or is that going to be like what it supplies? It's kind of odd. It doesn't do anything other than that try, though. That catch doesn't do anything. I might be misinterpreting that. But we get the path being supplied as the other argument and text being supplied as the other argument. So we look for files with a string path that is apparently just going to be passed to the text, and the extensions that will be supplied are exe and DLL. So for each of those items that we find, each of those files, we delete them. Okay. And then path 2 is set to an empty string. So both of these we end up going through, right? But list files, we get everything that's supplied in the other argument, all EXEs or DLLs, and then we combine them. Oh, sorry. Bring me back. Destination file name will be passed to combine that original text that we deleted with an EXE. If it is an EXE, then we save that and what would have been path 2. and then we try to copy it. Okay. And we run that. Process start on that process start info is now going to be that new. So that doesn't like actually update all that much. It's not like it's pulling down from the internet or anything. It's grabbing whatever files might be in the current directory. So if for whatever reason we got another DLL, we got another exe, maybe that was doing something to pull it in, I think? This is just a definition for that get file function that we were seemingly just calling earlier. We just grabbed that list information and grab it in extensions, right? Okay. So they're actually using real get files, seemingly. And checking if the extension matches and then returning it all. Okay. So I don't think this does a whole lot else, honestly. Let's kind of stop the system I/O thing from expanding because that is taking up a lot of space. But that update just seems to, for the program, do these things with exe files and like copy and delete them. Let's try and run it, you know, just to have some fun here. I'm gonna copy this Kaspersky.exe. I guess I can just download it from the other computer, right, if I need to again. But just to be like safe, let's disconnect from the internet. Not that like it's actually doing anything. Let's just disable this. Okay, and let's try and run that update. Even though we kind of looked through it and saw that it might just do some weird stuff with that other exe. Did anything happen? Did literally anything happen? I'm clicking on it a lot, but we could probably take a look at like sysmon or like sysinternals or anything to kind of process, examine that or see, make sure it's actually running. But how about if I like made another, I mean, are these all going to be in the same directory, right? Working directory, oh, it needs the arguments, duh. So we need to supply text, and we're looking for the path. So let's like simulate what this looked like to begin with. I'll go into C. Let's make, I mean, we already have a Windows directory. And I am in a virtual machine, right? So I can just kind of blow this thing up if for whatever reason it gets messy. Let's make a little Kaspersky directory, and you won't let me because I'm not an admin. I don't care. I will start up Windows Terminal as an admin. Let me do what I want. Am I actually an admin now? This is actually telling me. Let's try to make that directory again. Let's see how it looks. Yeah, all right, cool, did it. So let's copy everything from me, my desktop, all of those exe files. Let's put them right in this Kaspersky directory. And now let's, do I have the touch command? I do not. Silly PowerShell. Let's just echo nonsense into like a fake.exe because it's just seemingly checking for the file extensions, and I lost myself in a PowerShell prompt. Okay, so let's try and update the fake that is in C Windows Kaspersky. Am I understanding that right? I don't know. After the seemingly third argument, text should be what I've supplied as the file. Do I need to include the exe extension in here for some reason? No? Am I going down a rabbit hole? Honestly, this isn't obviously with this stuff going on, so we can table this. I think we've had our fun bumping around this update, but that doesn't exactly do much other than copy files. And I might be kind of getting in the weeds here and not exactly following what's happening because I'm done. So let's go do something else. Let's remove this update and let's try and add in. Yeah, we already nerfed internet, so I'm not concerned about that. Let's just pull in that Kaspersky.exe and let's see what we got, ladies and gentlemen. Kaspersky.exe 1.0.0.0.0. The assembly title is B. Assembly product is B. Copyright 2015. Yeah. Okay. So metadata, we don't want anything else interesting. The references that it pulls in, however, are, I think, peculiar, right? So you saw the DLLs in my Linux folder over here. If I hop back to that, you might have seen a net.dll. You might have seen a HiLabo or HageLabo, a Newtonsoft JSON.dll, S22. So let me kind of Google what these things are in case you might not be familiar with them. Because I wasn't, truth be told, right? The Newtonsoft JSON.net is a high-performance JSON framework for .NET. So it is going to be allowing us to use JSON inside of the code that we end up running, serializing it, working with it, deserializing it, etc., etc. So that we might see put to use. And the other one was HageLabo conversion. Let's Google that guy and see what this thing does. Or what is just HageLabo on its own? Because I just pulled in just that converter, but there was like a core, there was like other fragments of the library, but it provides mail client features for SMTP, POP3, and IMAP. So our little Kaspersky program might be sending some emails. Is that fair to say? We got JSON, we got mail functionality. What is this Sassel? What is this Sassel.dll? Let's grab him. See what he's up to. This supports authentication methods. So, yeah. This repository contains a .NET assembly implementing the authentication and security layer, or the Sassel framework. Provides a protocol or specifies a protocol for authentication and optional establishment of security layer between a client and server applications used by internet protocols such as IMAP, POP3, SMTP. I see. So a little bit more nod to emails and SMTP, right? Okay. Well, let's stop beating around the bush here. Let's go explore what this fun little Kaspersky.exe might be doing. Now we've got an idea as to what these other references that were included are. Actually, I'm curious still about that net one, but we can explore that in just a moment. Let's check it out. This does have seemingly some resources. Again, theoretically, it is supposed to be a GUI thing, so we can see what it exactly does. I don't know if you can see right here. I don't know if that's visible or not, but this is seemingly a namespace for a class kind of named SMTP Sender. So it has some enumerations here. We have connect status, it looks like, with value set for none, connect, and error. Load config file results, succeed, file not found, format error, and main form. Main form is a little bit hefty. There's a little bit more of that scroll bar there. So we have that default IP.txt file that we had seen. And checking out these references, right, of course, we see HageLabo, if I'm pronouncing that right, and the SMTP sender class itself, right? So, or the whole thing. I think namespace is the problem. I might be wrong in the terms that I throw out. I'm just kind of rolling off the cuff here. But create a main form, create an SMTP config, which looks like it's something that's defined over here. Cancellation token source, that is not defined elsewhere that I know of, seemingly. Last 60 cent count, last 60 cent timestamp, IP list, send mail. Tax, I'm assuming that should be task, maybe a list of tasks. IP list count, str IP list file name, current IP index, etc., etc., etc. So we're saving some IP addresses in this default IP.txt file. take that for what you will. Let's hop on over back to our Linux machine here, and in that related directory, I do have a default IP.txt. So let's just take a gander, you know? Let's take a look at what that might actually include here. I'll run cat and pipe that to less. Just a big long list of IP addresses, everybody. So I'm kind of curious what, there's a lot, by the way, there are a lot. I don't think I actually have Sublime Text installed in this VM yet. So how many of them are there? let's pipe that to WC TACL. Let's get the word count lines. Oh, 73,312, of course. Don't you need that many IP addresses for your antivirus program? I don't know. Let's cat that out one last time, and let's see where these IP addresses just like might be. Is there like a cheeky IP locator thing or IP location finder? Yeah, where's my IP address? I don't want you to tell me for myself. Actually, I just I don't need that. I do want to put it over here. Taiwan. I don't know how well you can see that. Is that does that have a domain? Hengen.com.tw in Taiwan? Let's go to it. Like, let's just do it. I mean, it's a thing. Okay. Let's check out this guy. How about you? Are you also in Taiwan? Ta-da! Nope. Israel. Okay. What about you? 72.52.170.252. Slap that in. Oh, that's over in, what was it, United States? It didn't tell me. Alright, where's the state that you were just showing me that I accidentally clicked out of? Wichita! Or somewhere close to it. Kansas. Okay. We could go down this rabbit hole for a while. Obviously, I'm not going to go through all 73,000 of them. Maybe we could write something that would move through it if we wanted to, but these are all over. We got Brazil, we got Israel, we have Taiwan, we have Kansas, the United States. What else we got here? Miami? Cool. All right, just one more, and let's get back to something more fun. It's over in Argentina. Let's take a vacay, guys. Yeah, all right. That's enough spooking around the internet. But as you can see, there are a lot of IP addresses, and maybe we could write something fun and funky to seal those locations. Let's do that in a different video, because that's not what we're doing in this one. Let's get back to our little Kaspersky.exe, so to speak. Let's check out load count, string header text, string body. So just based off of these variable names, I'm assuming in like all the references and the kind of the loaded in libraries that we've seen, SMTP robot, I'm going to assume that this thing is going to end up sending emails, right? Kind of somehow, some way, at some point. So what else we got? Here's the main form. And that is another, form here, initialize component. We should run this thing. we should see what this thing does. Get total memory in bytes. Okay, do a little reconnaissance, computer info. And that is an actual class. That's Microsoft thing. That's loaded in. Okay, Microsoft Equal Basic. Yeah, devices, it grabs that. Hey, how much memory do we have? What's my device info? But that uses some WMOC. CPU info, memory info, pulls it in for each management base object and management object searcher. And that looks like a WMI query for Windows management instrumentation. That's something, hey, let's grab in where it parses out the number of logical processors. Here, let's get CPU info, memory info, etc. Nito, get instance is going to return itself to the main form seemingly. Load config comes in from config data, which is passed in, and looks like we load from stream reader. That config was defined as a new SMTP config. So that might be something we could actually kind of follow through. Get count from file. Oh goodness, what the heck? We have a file stream object, read in with a file name, number, buffer size, read access, random access, seemingly that just looks like this. Counting the number of entries in the file, I think, maybe? Let's get the IP list of the file. Okay, that looks like the exact same thing. Looks like it's doing the exact same thing as counting. Start send mail task. Now we get to the weird stuff, right? Send mail task.clear with threads, adding new task to send with a robot, our robot status. Our SMTP robot, we got a completed function that just checks, hey, whether that robot status is stopped with 3 Ps or not. Same thing with the stop function, and it won't be reading. So is it like going through each of the IP addresses and trying to send stuff? Like every single one of those servers or something was, I don't know if that would be like the mail server itself, or I mean maybe. Like when we looked at that one in Taiwan, the HTTP had a domain to it, but I don't want to like obviously run nmap scan on something like that. But maybe that has port 25 open or anything for SMTP or IMAP or POP3. Spooky. We got log thread. Wait a second. Are those in the logs? It has strings like, oh, mail sent, okay. And authentication error? Authenticate error? Good after first. Oh, and it writes it to SMTP log.txt. Did we have that? It does explain thread. Oh, moving logs like everything does. The IP address, the port that it calls out to, the SMTP server, password. What? And the subject. That is neat. Also horrific, but neat. What do we got? We don't have SMTP log. No! Do we have log? What is that log.txt? I don't know what those are. But we didn't have an SMTP log. Okay, is that a dead end? Log good SMTP. Get use auth mode. HTTP client. Does it like check it? Oh. Does it like check to see if the server is up by like the HTTP thing? So that Taiwan one would maybe was up? I don't know.
do you need? I don't want any trouble. All done? You again. I don't want any trouble. Done? Well, you I don't want... All done? Well... You again. I don't want any... All done? Well, be on your way then. You dirty scoundrel. There was something off about you from the start.